In today's lesson, we're going to find unknown angles using inverse trig ratios. So just as a quick recap, one of the things we've seen is that sine 30 degrees, we can evaluate that, and let's just do that on the calculator to make sure we know what's going on there. So we have sine 30 equals 0.5. So therefore, the inverse of 30 degrees, 30 degrees is the inverse of sine 0.5. So 30 degrees is the inverse of sine 0.5. Okay, now the way we actually write this is we say sine inverse sine 0.5 equals 30 degrees. So we should have seen that already. We should have a basic understanding of that. If not, don't stress too much. We're going to look at a couple of examples and make sure we know what's going on. So the first thing I want us to do is just briefly look at how we enter these into the calculator. We're just going to evaluate these. So to do inverse sine on the Casio calculator, you press Shift, Sine, and you can see that brings up the inverse sine function, and then we can just punch the number into the calculator, 0.6294, close bracket. Now when we get these values, we're going to evaluate them to two decimal places. So we've got 39.01 degrees. Okay, let's do the next one. So again, we hold Shift cos. That brings up our inverse cosine function, 0.3110, close bracket, 71.88 degrees. And our last one is inverse tan, so Shift tan, 0.7409, close bracket. We end up with 36.54. That's just a quick recap of how to use the calculator. Let's actually dive into trying to solve some unknown angles. So here we have an unknown angle, and we've got some sides. So the first thing we always do with these triangles is label the sides that we have. So we've got our hypotenuse here and the adjacent. So we should remember that when we're looking at working with the sides of the adjacent and the hypotenuse, we're looking at SOHCAHTOA. So SOHCAHTOA. So we can see if we're talking about the adjacent and the hypotenuse, we're going to be using the cosine rule. So we've got cos theta equals adjacent over hypotenuse. So the adjacent in this situation is 12 and the hypotenuse is 63. This is where our inverse cos function comes into play. So what we can do to change sine effectively, we take the cos over to here. All we need to do is go theta equals cos inverse cos 12 over 63. And we can then just punch that into our calculator. So Shift cos 12 divided by 63, close bracket, 79.0 theta equals 79.02 degrees. So that's how we evaluate the unknown angle using the inverse trig ratios.